In this video, you'll learn how to use a third-party framework called picocli to make handling complex command line parameters simple while writing almost no code. We're going to use IntelliJ IDEA, the Ultimate Edition, to create our application. On the Welcome page, let's click the Create button. We're going to create a Spring Boot application, but picocli works equally well in a standalone application you might create for your DevOps pipeline. Spring Initializer is already selected, so let's give our project a name of pico-cli. We'll use Maven to build our project. Everything else here is fine, so let's click the Next button. Here we can add our dependencies. First, we want to add the picocli framework, so we'll search for pico. Notice it's grayed out, and to the right it says greater than or equal 2.6.0 and less than 3.1.0-M1. This means currently the picocli library supports and has been tested only with the Spring Boot code in that version range. At the top, version 3.1.2 of Spring Boot is selected, which is outside of that range. No problem. From the drop-down, let's select version 3.0.9. Now the Pico library is enabled and we can select it. We also want to include WebFlux so we can use the web client. Let's search for WebFlux, and that brings up the Spring Reactive Web Library. So let's check that box and add it to our dependency list. We're done with our packages, so let's click Create. IntelliJ calls start.spring.io using the information we provided and retrieves the generated code, loads it into IntelliJ, and builds our application. You might be wondering why we want to use a third-party CLI library when Spring provides a lot of the features right out of the box. Fair question. picocli makes it easy to define commands, options, and parameters that are far more sophisticated than the simple key-value pairs Spring Boot provides. picocli has a rich syntax that supports positional parameters, subcommands, and option groups for creating really sophisticated command line options. picocli will also generate robust documentation and usage statements for the parameters. And as we'll see, the iFactory interface can be implemented for creating clean, decoupled code. Let's take a look at the pom.xml file. We see the picocli dependency that was added, as well as the other dependencies. I'm running this code on a Mac using an M1 chip. I'm going to add a profile to my POM file so I don't get an error at runtime. I'll paste it in so I don't make a mistake typing. This is a profile that's automatically activated when I build the code with Maven on a Mac using an M1 chip. It adds a specific native Netty dependency that works for the Mac OS M1 architecture. If you're running on a Windows or Linux machine, you should be fine and won't need to make this change to your POM file. Let's look at the entry point for our code, the class that's annotated with Spring Boot application. This is pretty standard stuff. No changes to be made to this code. Looks like I forgot to refresh the Maven project after I made the changes. I'll click on the Maven refresh button so it can download any dependencies. Looks good, no errors, so let's continue. We'll create a new class called myCommand. This will be the code that will run the picocli command. We'll need to implement the callable interface, and we'll return a type of integer. This approach allows us to create a task that can be asynchronously executed and return the result of the action. We'll add the component annotation. This is a Spring annotation that allows Spring's dependency injection mechanism to manage instances of this class. We'll add another annotation, the command-line.command annotation from picocli. This designates the class as a CLI command. There are lots of attributes we can add using this command annotation, so we'll set a few of them. Name equals pico-cli, which is the name of the command. Version equals pico-cli-1.0. This can be seen from the command line when help is invoked. And last, we'll add description. This is the description of the command that can also be seen in help usage messages from the command line. We'll add a class variable, private, string, endpoint, and we'll add an annotation for that, command line.option. There are lots of attributes we could use, but we'll stick with the only mandatory attribute, names, and set it equal to -a and --address. When our code is executed, the value provided after the --address option will be stored in the endpoint variable for use in our code. Now let's right-click on the class definition and have IntelliJ add the method we need to implement. We'll come back and fill in the call method in just a moment. Let's add another variable, private web client of type web client, and we'll initialize it by calling the create factory for the web client class. We use the web client instance to make non-blocking web calls. Now let's create a method where we use the web client. Our method will be private, return an int. Let's call it getDogPhoto. There are no arguments, and we'll use the web client to make a get call. We'll specify the URI, which will be the value of the endpoint variable. We'll retrieve the result. The response body will be a stream of strings, and each string will be printed to the console. We'll assume everything will go well, and we'll return a status of 0, which indicates success. Keep in mind this is not production-ready code. And in our call method that was generated, rather than return null, let's return the result of the call to the getDogPhoto method. And that's it for this class. Now let's tie things together by adding a class that implements the command line runner interface. We'll create a new class and call it CLI runner. We'll implement two interfaces, command line runner and exit code generator. Let's implement and override the methods required by these interfaces by right-clicking and letting IntelliJ about that code for us. While we're here at the top of the code, let's add the component annotation so Spring Boot will manage instances of this class for us. We'll add some member variables. First is private final command line.ifactory. Our variable will be called factory. ifactory is used by picocli to create instances of command objects and dependencies. Next is private final myCommand of type myCommand. This will be an instance of the myCommand class we just created, which is an instance of the picocli command to handle our arguments. And finally is private int exit code. This will store the exit code after executing the command. Now we need to add a constructor to allow Spring to initialize the factory and myCommand member variables. We'll generate that code using IntelliJ. We'll select constructor. IntelliJ picks up the factory and myCommand member variables, so let's click OK. Now let's fill in our methods. First, for the run command, we'll set exit code equal to new and create a command line object, which comes from the picocli framework. We'll pass it our command and factory object references. Then we'll call the execute method of the command line class and pass in the arguments that were passed to our application. And in the getExitCode method, we'll simply return the exit code value. Okay, all done with coding. Let's open up Maven. We'll go to picocli, then Lifecycle, and Package, and let's run that. This will compile, test, and bundle our code as an Uber jar. When it's done, over in the target folder, if we open that up, we see the snapshot.jar that was created. Let's open a terminal window, then cd into the target folder, run ls. We see the jar file. Let's run that by entering java-jar picocli 001-snapshot.jar. We'll add -- address, which is what our picocli code is expecting, and we'll give it a location to retrieve some results. https://api.thedog.api.com/v1/images/search. And press return. Our code starts up like any other Spring Boot application. On the console, we see the result of our get call, an anonymous Java object with the result of the API call. If we click on the link that was provided, it loads up an image of what looks like a miniature Doberman Pinscher. Notice our Spring Boot application continues to run. We really just barely scratched the surface with picocli. It's a great way to process complex command line parameters in any Java, Kotlin, Scala, or Groovy application you might write. That's all for now. If you enjoyed this video, please like, subscribe, and share. Thanks for watching, and remember to always begin secure.